Dear students, welcome to the second class on circles of 10th standard mathematics. You have learned many concepts related to circles from the first class. I think that you have learned them all very well and tried problems given as homework. Today, we have to discuss what is an arc, alternate arc, central angle of an arc, angle made by an arc at its alternate arc like that. Then we will derive some theorems. After that we will do some problems. Okay, then I welcome you all once again to this class. Be attentive. At first, let us check what is an arc and alternate arc. First, an arc. An arc is a piece of a circle. See, an arc. It is a piece of a circle. It need not be a small piece like that. It can be a large piece like this also. Therefore, an arc is a piece of a circle. You can write down such a figure and write what is an arc like this. Arc is a piece of a circle or a part of a circle. Now, let us think about alternate arc. Alternate arc means when two arcs together determine a complete circle, we call each one of them as the alternate arc of the other. Here see, when this red colored smaller arc is attached with this blue colored longer arc, we get a complete circle. Therefore, each one of them is called the alternate arc of the other. Let us name the endpoints of this red colored by A and B. Usually, an arc is named by 3 points and 2 endpoints and any one point in between the endpoints. Let it be some P like that. Now let us name the larger arc by AQB like that. We see to arc APB, arc AQB is its alternate arc. Like that, when arc AQB is considered, arc APB is its alternate arc. Therefore, alternate arc means when we attach two arcs together or when two arcs together determine a complete circle, we call each one of them as the alternate arc of the other. Here, arc APB is the alternate arc of arc AQB and vice versa. Draw such a figure and write down this explanation there. Now, let us think about the central angle of an arc. What is the central angle of an arc? When the endpoints of the arc is joined to the center of the circle, we get an angle at the center. Here, arc APB is considered. Its endpoints A and B are joined to the center O of the circle. We get an angle at the center, angle AOB. We call angle AOB as the central angle of arc APB, or it is the angle made by the arc APB at the center. See the central angle of arc APB. See the central angle. Therefore, central angle of an arc, you can write down the explanation like this. Draw such a figure and write down this explanation there. Central angle of an arc means it is the angle made at the center by an arc, or it is the angle made by joining the endpoints of the arc to the center. Okay, draw the figure and write down this one. Now, when arc AQB, the longer arc, is considered, its central angle will be here. See the central angle of the longer arc AQB. Now we see when these two arcs together considered, they form total angle around a point. You see, when these two angles together considered, their sum will be 360 degree. That means sum of the central angle of alternate arcs, sum of the central angle of alternate arcs together determine angle around a point. Therefore, their sum is 360 degree. Write down this one. Draw such a figure and mark these two angles, and then write down this explanation there. This result there. Sum of central angle of an arc and its alternate arc together is 360 degree. Okay, now let us go to next. Consider arc APB. Its endpoints are joined to a point Q on its alternate arc the figure will be like that. We have joined the end points of the arc APB to a point Q on its alternate arc. This angle obtained is told as angle made by the arc APB at its alternate arc. We have to find the relation between these two angles. We have to show the angle made in the alternate arc is half of the central angle of the arc. Mean this angle is half of this one. For this, let us first measure central angle of arc APB. Mean let us measure angle AOB. See the angle. And let us measure angle AQB. See angle AQB, that is this angle is half of this one. If we vary the central angle of the arc APB, mean if we elongate or reduce the length of arc APB, at that time its central angle changes. At that time the angle in the alternate arc also try to keep half the central angle of the arc. See, it always trying to keep half of the central angle of the arc. Now we have proved if the end points of an arc is joined to a point in the alternate arc, that is angle in the alternate arc, we see that angle is half the central angle of the arc. In the case of smaller arc, what we find, the same can be found in the case of larger arc also. See, here the arc is smaller. If we take a larger arc AQB, when their end points are joined to a point in the alternate arc, the angle obtained in the alternate arc will be here. We have to prove this angle APB is double of the central angle of arc AQB. Now the central angle of arc AQB is there here marked. See the measure. Now the angle in the alternate arc, see the angle APB. There also we see this one is half of this much. Now irrespective of the size of the arc length, whether it is smaller or larger, if their end points are joined to a point in the alternate arc, at that time angle in the alternate arc is half of the central angle of the arc. That can be proved mathematically. See the figure. We will prove this one as two cases. Mean at first we will prove for smaller arc, then for the larger arc. Here let us prove it for the smaller arc APB at first. Let us prove this one by a question. You can write down a question at first. By answering that question, we will have done the proof for what we have been discussing. Okay, here you can write down such a question and such a figure, then we will think how it can be answered. At first, let us join OQ. Let us join OQ. At that time, we will get such a figure. See, now we get two isosceles triangles here. As all these are radii, these two are isosceles triangles. And so what much measure here it is given, the same measure is there here. If we suppose this angle by x, the angle at this vertex is also x. Like that here this one is also an isosceles triangle, mean if we suppose this one by y, this angle also will be y. That means if one angle is given as y, at that time this angle is also y. Now come back to this triangle. We say this angle is x plus y, that is angle in the alternate arc is x plus y. This total angle is now x plus y. We have to get this one 2 times of this, that is we expect this one to get 2 times of x plus y, then we will have done. Now let us have it done like this. Here this one x mean this angle will be 180 minus 2x. This one y mean this angle will be 180 minus 2y. Now to get this one, our aim is to find out this one. That can be found by subtracting from 360 the sum of these two angles, because total angle around a point is 360. To get this one from 360 we have to subtract the sum of these two. Okay, that can be found later. Now let us write the steps that we have been discussing. After writing the steps we will get what we want to get, its measure. Okay, here we have considered, let us write the steps like this. APB is an arc, AQB is the angle in the alternate arc. We have to prove AQB is half of central angle of arc APB. Okay, this proof should be written in your notebook, and the first step for the proof is this one. what we have supposed at first and what we have done like that, what we have to proved. Now the next step is we have supposed this one x, therefore this one is also x, so that this one is 180 minus 2x. See, like that this one y, so this will be 180 minus 2y. Now to find out this one that we have told, from 360 we have to subtract the sum of these two angles. Angle AOB is equal to, from 360 minus the sum of the other two angles. That means this measure will be from 360, we have to subtract the sum of these two angles. Now see the bracket. Inside the bracket, two 180s are there. Their sum is 360. Then on getting this minus 360, it will cancel with this 360. Now inside the bracket, a minus 2x and minus 2y, on getting this minus, it will be plus 2x and plus 2y will be there like that. Okay, and it will be 2 times of x plus y. That we have got this angle as 2 times of this one. That is, angle AOB is 2 times of angle AQB. Okay, that step let us write it here. As there is no space here, I am writing the remaining. You can write down in your notebook as the continuation of this one. Therefore it is angle AOB is 2 times of angle AQB. This angle is double of this one. The same telling in other way, this angle will be half of this one. Okay, that is written at last like that. We have proved now angle AQB is the angle in the alternate arc made by the arc APB. Therefore that angle is half the central angle of the arc APB, that we have proved. This one is half of our central angle of arc APB, mean half of angle AOB. Now we have proved in the case of a smaller arc, when their endpoints are joined to a point in the alternate arc, then the angle obtained in the alternate arc will be half of the central angle of the arc. Now let us prove this one for the longer arc also. Okay, let us try. Now let us consider the longer arcs case. Okay, if we consider the longer arc, when their endpoints are joined to a point on its alternate arc, how will be the figure? Okay, now AQB is the longer arc. Their endpoints A and B are joined to a point P on its alternate arc. That means from A and B we have to join to P, then it will be such a figure. We see here an angle is made, angle APB. We have to prove that angle should be half of the central angle of arc AQB, mean this much angle should be half of this much. Okay, this angle APB is half the central angle of arc AQB, that we have to prove. For this, let us join O and P, and so we will get such two triangles then. What is the speciality of these two triangles? We see that these two triangles are isosceles as their two sides are radii. And so if we suppose this angle by x, this angle also is x, so that this will be 180 minus 2x. Let us give it like that. Let us suppose this one by x. If we suppose that one by x, this angle is also x. Okay, now this will be 180 minus 2x. Like that, here this angle can be supposed as y, so that this angle is also y. So this third angle can be supposed as, can be found as, if this one y mean this will be 180 minus 2y. Okay. Now we can tell how much is this angle. That means that angle is to be found. This angle is to be calculated. Okay. Now we know we need to get, if this angle is, from figure we see this angle is x and y together, x plus y. That is, angle made in the alternate arc is x plus y. We need to get this much angle, that is this angle, central angle of arc AQB, as 2 times of this one. Mean we have to get this one as 2 times of x plus y. That we will get by writing these all steps. At last we have to get this one as 2 times of x plus y. And so before writing this step, you have to draw this figure there in your notebook and write this step at first like this. What we have supposed here, that should be written at first. Here AQB is the arc under our consideration. Angle APB is the angle made in the alternate arc. we have to prove angle APB is half the central angle of the arc AQB. That should be your first step to be written. Okay, and so you can write down these things like that. And what we have been telling, it is there here. Now we have joined this one, and this angle is supposed as x, so this one is x, therefore this will be 180 minus 2x. That is our second step. Like that, this one is supposed as y, then this one is also y, so that this one is 180 minus 2y. Okay, now here we have to calculate this angle. Okay, that angle, we know angle around a point is 360. Therefore, this angle will be from 360, we have to subtract this much angle, mean the sum of these two angles. Therefore, central angle of arc AQB will be from 360, we have to subtract the sum of other two angles. See, central angle of arc AQB is equal to, from 360, we have to subtract the sum of these two. It is written there. Okay. Now inside the bracket, two 180s are there. Two 180s will be 360, and this minus symbol make it minus 360 will get cancelled by this 360. And so there it is left inside the bracket minus 2x and minus 2y. On getting this minus, that will be plus 2x and plus 2y. Okay, 2 can be taken out, it will be 2 times of x plus y. We expect such a measure to this angle, 2 times of x plus y. That means if this angle is x plus y, we expect this one as 2 times x plus y that we have obtained. Okay, 2 times x plus y mean 2 times of angle APB. 2 times of angle APB. Okay, that means central angle of arc AQB is 2 times of angle APB. If we tell it in other way, angle APB is half of the central angle of arc AQB. That means in that case also we have proved, that means in the case of the longer arc also we have proved, when their endpoints are joined to a point in the alternate arc, the angle obtained in the alternate arc will be always half of the central angle of the arc. Now let us write the result. Angle made by an arc at a point of its alternate arc is half the central angle of the arc. Write down this result in your notebook and put that one in a box. Very important result it is. Okay, now see the figure. Here APB is an arc, angle AOB is its central angle. Okay, if we join the end points of arc APB, that is A and B, to a point Q on its alternate arc, we will get an angle there at its alternate arc. We have proved that this angle will be half of this one. Okay, like that, if we had joined the end points of the arc APB A and B to some other point C on its alternate arc, there also we will get an angle like that. That angle also will be half of this one. Mean these two angles are half of this angle, mean they are equal. If we had joined the end points of the arc APB to some other point here somewhere and join the end points to that one, then also we will get an angle. We can see that angle also will be as that of these two angles, mean all those angles are equal. All those angles are in the arc AQB, mean we have got a result, that is all angles in the same arc are equal. All angles in the same arc are equal. When we think from the side of APB, they are all angles made by the arc APB at its alternate arc. Therefore, let us write the same thing like this. All angles made by the arc APB at its alternate arc are equal. Okay, let us write these things here like this. Here AQB and ACB are angles made by the arc APB at its alternate arc, and their measures are half of the central angle of the arc APB, hence they are equal. Hence angles in the same are equal, and angles made by an arc at a point of its alternate arc are equal. Let us write these things like that. You have to draw such a figure at first, then write down this argument in your notebook. Pause the video and draw the figure, then write this. Okay, the result we obtained from this discussion is that the result is, you can write down the result in a box like this. See the result. All angles made by an arc on its alternate arc are equal. In other words, angles in the same arc are equal. See, here we have made all angles along this way. If we had made angles along this way, what will be the case? Let us check. See, all angles are made along the other way. How will be then the result? See, that means let us join the end points of the arc AQB to a point on its alternate arc. Therefore, the figure will be like this. We will get an angle there. We see that angle will be half of the central angle of arc AQB, mean this angle will be half of this much angle. That means this angle will be half of this. Like that, if we had taken some other point here somewhere, at that time also when we join the end point of the arc AQB to a point on its alternate arc, at that time the angle made there will be half of this one. Mean these two angles are half of this one, mean these two are equal. Mean angles in the same arc, they are angles in the arc APB. Angles in the same arc are equal. When we view that one from the side of AQB, they are all angles made by the arc AQB at its alternate arcs, they are equal. Hence we will get the same result. Okay, that second figure you need not to draw. You need not to draw, that I just mentioned. You need only to draw the first figure and you will have written it there. Okay, now let us make another result that you have learned. Sum of the central angle of an arc and its alternate arc together determine 360 degree, that we have already discussed. Sum of the central angle of an arc and its alternate arc together determine 360 degree. Consider arc APB. Its central angle is angle AOB. See, arc APB and its central angle is angle AOB. If we suppose that angle is measured by C, when the end points of the arc APB join to a point on its alternate arc, we will get an angle there. We have found that angle will be half the central angle of the arc, mean this angle will be C by 2. Okay, if this angle is C, this will be C by 2. Like that, if we take into account the arc AQB, let us take its central angle by D. Okay, consider arc AQB, its central angle is there here. Let us suppose it by D. We have taken that much measure by D. When its end points of arc AQB, A and B are joined to a point P on its alternate arc, we will get an angle there. We have found that angle will be half of the central angle of arc AQB, mean it will be D by 2. As the central angle of arc AQB is D, this will be D by 2. Now see, central angle of arc APB and central angle of arc AQB, that is C and D, together determine angle around a point. Therefore, their sum is 360 degree. We have already proved sum of the central angles of an arc and its alternate arc together determine 360 degree. Therefore, these two are 360, mean their halves determine 180. Two measures giving the sum 360 is considered, their halves together gives 180 degree. That means these two angles, when we view APB and AQB, they are alternate arcs, and so these angles are angles in the alternate arcs. We see their sum is 180 degree. Hence we have made another result. Okay, now let us write these steps like this. Angles in the alternate arcs are together determine 180 degree, that can be told like that. Angles in the alternate arcs are supplementary, mean their sum is 180 degree. To prove that one, we have supposed angle arc APB and angle AQB as alternate arcs, and C and D are their central angles. Therefore C plus D is 360 degree. Let us draw this figure first, then write those statements like that. You can draw such a figure at first, then write these steps in your notebook. Okay, we have supposed APB and AQB as alternate arcs, their central angles are C and D, their sum is 360 degree. Okay, now from the figure we see AQB is C by 2 and APB is D by 2. That we can see from the figure, and from the result we have already made. You can write such a step next. And so on adding these two, angle AQB plus angle APB, mean it is C by 2 plus D by 2. C by 2 plus D by 2 mean both of them get the same denominator 2, therefore it is C plus D by 2. We know C plus D is sum of the central angle of an arc and its alternate arc, it is 360. Therefore C plus D by 2 will be 360 by 2, that's equal to 180 degree. C 360 by 2 equal to 180 degree. That means these two angles gives the sum 180 degree. Hence we have proved, that is angles in the alternate arcs are supplementary. Let us write the result. Angles in the alternate arcs are supplementary. See, angles in the alternate arcs are supplementary. Here these are angles in the alternate arcs. When APB is considered, this angle is angle in the alternate arc. When AQB is considered, this angle is angle in its alternate arc. Therefore when they are added, the sum will be 180 degree. Therefore angles in the alternate arcs are supplementary. Very important result. Pause the video and draw the figure and write down these steps and write this result at last. Put that one in a box. We have got many results regarding a circle. Now let us apply those results in some constructions. See the question. Here a 23.5 degree angle is to be constructed. You know, an half degree angle cannot be constructed using protractor directly. And so if we could draw an angle with the double of this one, that means a 47 degree angle is there, you know to bisect it. That method you have learned, that you have done in the smaller classes. But here we have to think, we have to get this 23.5 degree using the result that we have just formed. You know, if the endpoints of an arc is joined to a point of its alternate arc, the angle made there will be half the central angle of the arc. And so if we make an arc with the central angle double of this one, then that means double of this one means if we make an arc with the central angle 47, at that time the angle made by that arc at its alternate arc will be half of that one will be 23.5. And so that is the method here we have to adopt. And so let us make a circle and arc with the central angle 47 degree in it. At first let us make a 47 degree angle. See, a line is drawn. Let us make a 47 degree angle at its end point by keeping compass there. And so where 47 fall, put a dot, then we have to draw a line along that way. See, when we have drawn such a line, we see this angle will be 47 degree. Now keeping compass here, taking any distance, convenient distance as radius, you can draw a circle. And so when you draw such a circle, you will get that circle meet at 2 points on the sides of the angle. And we see here we get an arc. The central angle of that arc is 47 degree. When the end points of that arc are joined to a point on its alternate arc, we see there an angle is obtained. That angle will be half the central angle of this, mean this will be half of 47. That means that angle is 23.5. Now we have constructed a 23.5 degree angle. You can pause video and draw such a constructions. If you want to write down the steps needed, you can have it written how such a one is made. Okay. Now, instead of this 23 and a half, suppose you are asked to construct a 22 and a half, but one condition is there you are not allowed or you are not permitted to take at any time the protractor. And so here to get 22.5, you need to make here, it's a double 45. And how 45 can be made? In the same way, you can think that 45 can be made by an arc with the central angle. It's a double 90 degree. That means if a 90 degree arc is there with a arc with central angle 90 degree is there, this angle must be angle in its alternate arc so that it will be 45. And so the next, how a 90 degree can be made? For that, let us take the first result that you have formed. Angle in a semicircle is right angle, and so you need to draw a semicircle first, then an angle in it. Then on doing this process on that figure, we continuously at last we will get 22.5 degree angle. That can be done. Let us have one more example. See the question. Here we are asked to construct a triangle with the two angles 30 degree and 70 degree and circumradius 2.5 centimeter. Mean you have to draw a triangle with all its vertices on a circle of radius 2.5 centimeter, and two angles of that triangle should be 30 degree and 70 degree. To construct such a triangle, first let us construct a circle of radius 2.5 centimeter. And so let us measure a radius of length 2.5 centimeter. 2.5 centimeter is measured. Now this much distance is taken as the radius. Now here let us take this point as the center of the circle. Now in the question it is said one angle of the triangle is 30 degree mean. At that time, we have to make a 60 degree angle at first. Its purpose will be explained later. Here 30 degree is one angle of the triangle. Let us make it's a double angle at the center. That means a 60 degree angle here let us measure in protractor. Okay, from this line a 60 degree angle is to be made. Now where 60 falls, 60 degree fall, we have to measure from this side where 60 falls, put a dot. Now we have to join that 2 points. We see we will get a point on the circle making 60 degree angle. Now that angle is 60 degree. See. Now it is said in the question another angle of the triangle is to be 70 degree mean. Here we have to make its double at the center. Okay, we have to measure a double of 70 mean 140 degree angle made from this line. A 140 degree angle is to be made from this line. Okay, so that we have to keep the protractor here and we have to measure a 140 degree angle. From here we have to start to measure. Okay, where 140 fall, we have to put a dot there. Then the line is joined. A point will be obtained that angle is 140 degree angle. By doing this much activities, we have obtained 3 points on the circle. See, let us join that 3 points. Then we will get a triangle. Now, what about we can tell the angles of the triangle? Definitely that triangle get its circumradius 2.5 centimeter because its all vertices lie on a circle of radius 2.5 centimeter. Then here this one is an arc. Its a central angle 60 degree. Okay, so that this angle will be half of that one will be 30 degree. That means this triangle get one angle 30 degree. Here 60 degree is there, so we could make here this one 30 degree. That is the purpose that I have mentioned, that if this angle is 60 degree, this one will be 30 degree. Here this arc gets its central angle 140 degree mean. This one is the arc with the central angle 140 degree mean. This angle will be angle made by the arc at a point of its alternate arc, so that this angle will be half of that one mean. This will be 70 degree. So that we have done all the conditions given in the question. Okay, this triangle gets its circumradius 2.5 centimeter and two angles 30 degree and 70 degree. Hence we have done. Now let us solve some textbook problems. See the first question. Read the question. Here it is told O is the center of the circles. In all the case, O is the center. We are asked to determine angles of triangle ABC. We see angles of triangle ABC. Triangle ABC are different in every cases. Triangle ABC are different triangle in all these figures. We are also asked to determine angles of triangle OBC. Triangle OBC. In every cases, triangle OBC are different. See, they are all different triangles. Let us do with the first figure. Here, let us redraw the figure. Okay. Then, when we have drawn it again, let us do the activities on that figure. Then, see here. Let us first join OA. Join OA. We see now it is made into two isosceles triangle. Here an isosceles triangle is there. There also an isosceles triangle is there. If this angle is 20 degree, this angle is also 20 degree. If this angle is 30 degree, this angle is also 30 degree. See. Now, this total angle A is equal to 20 plus 30. That is 50 degree. Therefore, we have determined one angle of triangle ABC 50 degree. Now let us calculate angle B, then this total angle. For this we need only to get the central angle of arc AC. Central angle of arc AC can be obtained from this triangle. Here it is 30 degree, so that this will be 180 minus the sum of two 30s will be 60. 180 minus 60 will be 120, so that this will be half of that one will be 60 degree. Now we have determined all angles of triangle ABC. Let us write these much steps. Here we have obtained OAB and OAC as isosceles triangle. First redraw the figure, then write these steps as answer. Okay, answer. It is first we have joined line OA, then these two triangles are isosceles. We see that two triangles are isosceles. Therefore, this angle is 20 and this one is 30. Let us write that one. Then we see this total angle is 20 plus 30, that is 50 degree. Okay. Now to determine angle B, let us think about angle AOC. Angle AOC will be from 180. The sum of these two 30s, that is 60, is subtracted. Therefore, 180 minus 60 will be 120 degree. Now angle B is equal to half of 120, that is 60 degree. Now we have calculated angle B. Angle is obtained as 50, angle B is 60, so that angle C will be from 180. We have to subtract the sum of these two. 50 plus 60 will be 110. 110. That is, therefore, subtracting that from 180, it will be 180 minus 110 is equal to 70 degree. This angle will be 70 degree. Therefore, angles of triangle ABC are 50 degree, 60 degree, and 70 degree. And so the remaining steps are, we have to subtract from 180. The sum of that, the other two angles, we will get 670. Therefore, all angles of triangle ABC are calculated. Now, let us think about the angles of triangle OBC. See, angles of triangle OBC is to be calculated. For that, see, here angle BOC will be double of this 50. Angle BOC will be double of 50, mean angle BOC, this angle will be 100 degree. If this one 100 degree mean triangle OBC is isosceles, therefore these two angles are equal and their sum is from 180. When 100 is subtracted, the remaining angle is 80. Therefore that 80 should be divided equally among these two angles. Therefore each angle should be 40. And so let us write the remaining steps to get the angles of triangle OBC as, first of all, angle BOC is 2 times of 50, that is 100 degree. Then the other two angles, these two angles are from 180, we have to subtract 100, that is 80. It should be divided among these two will be 40 each, like that. Now we have done the answer to the first figure. Okay. Now joining here in the second figure OB, and in the third figure, by getting this angle with the property of isosceles triangle, we are able to determine all angles of triangle ABC here, and all angles of triangle OBC can be obtained from these two figures as we have done here. Here we have to think angle made by an arc at a point of its alternate arc is half of the central angle of the arc. All angles in the same arc are equal. Those and angles of now two angles of an isosceles triangle are equal. These much things are needed to get the answers to these questions. That part is left to you as homework. Do yourself. Now let us try another question. Read the question. See the figure, then read. In the figure it is said O is the center of the circle. A, B, C are points on the circle. We are asked to prove angle OAC, that means this smaller angle added with this one angle ABC gives 90 degree. That means this smaller angle plus this angle together, when stand together added, we get 90 degree. That we have to prove. And so to answer this, let us redraw the figure, then let us make some additional constructions on it. Therefore we will get a figure like this. See, when we have redrawn, we will get such a figure. Let us join OA. On joining OA, we see there an isosceles triangle is obtained. Triangle OAC is an isosceles. Whatever measure we give to this angle OAC, the same measure will be there to angle OCA. Okay, let us give angle OAC by x. Then this angle also will be x, as that one is isosceles. Now angle AOC is equal to, that angle will be equal to 180 minus 2x. Since this one is 180 minus 2x, that means this one is the arc made by this arc at a point of its alternate arc. Therefore that angle will be half of this one. That angle will be half of that one, mean half of 180 minus 2x equal to half of 180 minus half of 2x will be 90 minus x. We see that angle will be 90 minus x. That means this much angle is 90 minus x. This smaller angle is x. That is 90 minus x plus x is equal to 90. Hence we have done. Now let us write these steps like this. See, the first we have to join. We have to join O and C. Then we have considered it as an isosceles triangle. There it is joined. Then we see it is an isosceles triangle. Therefore angle OAC is equal to angle OCA. Both are x like that, or simply angle OAX, angle OAC equal to x. If that one is x, this angle is also x. Mean this one is 180 minus 2x. Therefore this angle will be half of that one. Mean 90 minus x. This angle will be 90 minus x. If we suppose this one x, this will be obtained as 90 minus x. Then on adding these two angles, 90 minus x plus x, definitely it will be 90. Okay, that angle, the sum of the two angles will be 90. Then x and minus x on consideration, 90 is left. Therefore we got the answer. Now we have done the question 5 in the page 52. Now let us do one more problem. See the question. Read the question. It is set AB and CD are two mutual perpendicular chords. We have to prove arc APC and arc BQD together determine half of a circle, mean they together attached we must get a semicircle. To show that one, it is needed only to show sum of the central angles of arc APC and arc BQD together gives 180 degree. For this, let us redraw the figure. See, and let us name the meeting point of the chords by M. Then when A and D or B and D, let us join A, D or BD. Any one can be joined, or AC or BC, whatever be. Let us join, for an example, AD. On joining A and D, we get a triangle AMD right angled. See, let us name this angle by X. Here let ADM be X and MAD be Y. We see X and Y together gives 90 degree, because total interior angle of a triangle is 180. If this angle alone gives 90 degree, means these two angles together gives 90 degree. So the total will be 180 degree. Now see arc APC. The angle made by that arc at its alternate arc is X. Therefore central angle of arc APC is its double 2X. Like that arc BQD, that one make an angle at its alternate arc, that is Y. Therefore the central angle of arc BQD will be, that is the angle made at the center of the circle, will be 2 times of this one, 2Y. Now X plus Y gives 90. Therefore central angles of arc APC and arc BQD, when added, it will be 2x plus 2y, that is 2 times of x plus y. X plus y is 90, therefore 2 times of x plus y will be 2 90s, that is 180 degree. Hence we have proved sum of the central angles of arc APC and arc BQD together gives 180 degree, mean they together determine a semicircle or half of a circle. And so we have done the proof, and let us write the steps. Okay, we have to, when we write the answer to this question, we have to redraw the figure first, and after drawing such a figure, you have to mention which are the activities that we have done here. Here we have joined A and D first. Let us write that one, joined A and D. Okay, then we recognize this one is a right angle triangle. Write down that one. Now if we suppose this one X, this one is Y, that we have told. Therefore X plus Y gives 90 degree. See, now central angle of arc APC will be 2 times of this, because this one is the angle made by that arc APC at its alternate arc. If that angle is X, central angle of arc APC will be 2 times of X. Like that central angle of arc BQD, looking here we can tell central angle of arc BQD will be 2y. Now their sum of the central angle, we need to find out the sum of the central angles of these two arcs. When they are added, it will be 2x plus 2y. 2x plus 2y is 2 times of x plus y. X plus y is 90, therefore 2 times of x plus y will be 2 90s, that is 180 degree. We have proved sum of the central angles of arc APC and to arc BQD together gives 180 degree, mean when they attach to together it will be a semicircle, or they together determine half of a circle. Hence we have done the proof. We have been doing some problems in the pages 51, 52 and 53. Now the remaining works in those pages, question number 2, 3, 4, 6, 8 are left to you to do yourself as homework. Try yourself. If you are in trouble, we will clarify it in the next classes. Okay, thanks.